Look up at a clear night sky, and you are seeing almost nothing. Every star, every galaxy, every glowing cloud of gas you could ever observe adds up to a small fraction of what is really out there. The overwhelming majority of the universe is invisible, and we still do not know what it is. The first clue came from the way galaxies turn. A galaxy is a great wheel of stars, slowly rotating. By the simple laws of gravity, stars far from the center should orbit more slowly than those near it, just as distant planets orbit the sun more slowly than near ones. But when astronomers measured real galaxies, the outer stars were moving just as fast as the inner ones. Far too fast. At those speeds, with only the visible matter to hold them, the galaxies should be flinging their own stars out into the void. They should be tearing themselves apart, and yet they hold together. Something is providing the extra gravity needed to keep those racing stars in their orbits. Something with mass, but giving off no light at all. The galaxies are wrapped in a vast, invisible grip, and the stars we see are just the bright tip of it. This was the discovery, refined through the 1970s by careful measurements of galaxy after galaxy. The pattern was everywhere. Every spiral galaxy seemed to be embedded in a huge halo of unseen mass, far larger and heavier than all its stars combined. The galaxies were not alone in the mystery. Decades earlier, an astronomer studying a great cluster of galaxies had found the same thing on a larger scale. The galaxies in the cluster were moving so quickly that the cluster should have flown apart long ago. Something unseen was binding it. Whatever this stuff was, it had mass and gravity, but it did not shine, did not absorb light, did not glow in any color we could detect. So it was given a simple, honest name for our ignorance: dark matter. Not dark as in black, but dark as in hidden from every kind of light. There is a way to see the invisible. Mass bends light. A heavy enough object warps space around it, so light passing nearby is deflected, like a lens. By measuring how the light from distant galaxies is bent, astronomers can weigh the unseen mass in the foreground, even though they cannot see it. When they did this, the verdict was overwhelming. Cluster after cluster bends light far more strongly than their visible matter could ever explain. The lensing maps reveal great unseen reservoirs of mass, vastly outweighing the stars and gas. The dark matter was not a fudge. It was massive, and it was everywhere. At first, there was an obvious suspect. Maybe the missing mass was just ordinary matter that happens not to shine. Cold gas, burnt-out stars, lone planets, small black holes drifting in the dark. Things made of the same atoms as us, simply too faint to see. That idea ran into a wall. The amount of ordinary matter in the universe is tightly constrained by the physics of the Big Bang and by the oldest light in the sky. There simply are not enough atoms of any kind to account for the missing mass. Dark matter cannot be ordinary stuff hiding in the dark. That conclusion is staggering. Dark matter is not made of atoms. It is not protons and neutrons and electrons, the ingredients of everything you have ever touched. It is some other kind of matter entirely, a substance outside the ordinary contents of the world, and it dominates the cosmos. Whatever it is extraordinarily shy. Dark matter feels gravity, but otherwise it seems to ignore the rest of reality. It does not bump into ordinary matter, does not stick, does not glow. Vast rivers of it could be streaming through this room right now, through you, and you would never feel a thing. Physicists have proposed candidates. Perhaps it is a heavy, sluggish particle left over from the Big Bang, interacting only weakly with everything else. Perhaps it is an incredibly light particle, swarming in unimaginable numbers. Each idea predicts something we might one day catch. None has been confirmed. To catch it, we go to the most unlikely places. Deep beneath mountains, shielded from all other radiation, sit ultra-sensitive detectors waiting in the dark. They are hoping for the faintest possible flicker, the rare moment a dark matter particle bumps an ordinary atom just once. We also try to make it. In the great particle accelerators, beams collide at enormous energy, and physicists watch for an unexpected gap. a slice of missing momentum that would betray an invisible particle slipping away unseen. So far, the gaps have not appeared. The dark matter has not shown its hand. Even unseen, dark matter has shaped everything. In the early universe, its gravity pulled ordinary matter together, building the scaffolding on which galaxies formed. Without it, the cosmos would be a thin, smooth haze, with no galaxies, no stars, no us. It is the hidden architecture of reality. The amount of dark matter is not guesswork. The faint ripples in the oldest light in the sky encode the recipe of the universe, and they demand it. About 5 times as much dark matter as ordinary matter. The number is precise, even though the substance itself remains a complete mystery. One observation stands out above the rest. When 2 great galaxy clusters smashed together, the ordinary gas slowed and piled up in the middle, glowing in collision. But the mass, mapped by its bending of light, sailed straight through, out ahead of the wreck. The dark matter and the visible matter had separated. That was as close to seeing dark matter as we have come. The bulk of the mass was somewhere the visible matter was not. It is hard to explain that with any trick of ordinary physics. Something with mass and almost nothing else had drifted clean through the crash. Not everyone is convinced there is a new substance at all. Some physicists ask a bolder question. What if our law of gravity is simply incomplete on the scale of galaxies? Modify gravity in the right way, and perhaps the fast-spinning stars need no hidden mass to explain them. It is a serious idea, and it explains single galaxies surprisingly well, but it struggles with the bigger picture. The separated clusters, the lensing maps, the ripples in the old light. To match all of it at once, modified gravity has to strain, while a real unseen substance fits naturally. So the mainstream view holds. The universe is built mostly of things we cannot see. Ordinary matter, everything that glows, is a thin frosting. Dark matter outweighs it many times over, and beyond even that lies dark energy, stranger still. The familiar world is the exception, not the rule. Decades of searching, ever more sensitive detectors, ever larger surveys, and still no particle of dark matter has been caught in the act. We know it is there from its gravity, written across the whole sky. We just do not know what it is. It is the largest open question in physics. Picture the galaxy you live in. Not as a flat, bright spiral, but as a small glowing disk sitting at the heart of an enormous invisible sphere, far larger and heavier than all its stars. We live deep inside a halo of darkness, and we have only just realized it is there. And it is not only out there. Our whole galaxy drifts through a sea of this stuff, which means a faint wind of dark matter is blowing through the Earth, through these very words, through you, every second of every day. Unfelt, unseen, and utterly ordinary to the universe. There is something bracing in all this. We have mapped the invisible, weighed it, watched it bend light and drift through colliding clusters. We have measured exactly how much of it there is, and we still cannot say what it is made of. The universe keeps its largest secret in plain sight, but the hunt is narrowing. Each silent year rules out possibilities, sharpening the search. The next great detector, the next survey of bent light, the next collision deep in an accelerator, any of them could finally catch the universe's hidden majority in the act. The answer may be close. So remember, the next time you marvel at the stars, that you are admiring the smallest part of the cosmos. The grand glowing galaxies are mere decoration on a vast invisible structure. Most of everything is dark, silent, and waiting, and it has been holding the universe together all along. Dark matter is the universe's quiet confession that we are newcomers to our own home. We have learned to read the sky in light, and the sky has told us that light shows almost nothing. The real cosmos is mostly a shadow, and learning its nature may be the work of a generation.